description of our session: using technology and analytics to optimize operations and enhance integration between operations and customer service. Discussion topics include establishing the foundational technologies and integrations today to prepare utilities for the future, more distributed, customer-engaged energy delivery system, in a more engaged customer energy delivery system. Readying the infrastructure to engage at the edge and prepare for a more transactional environment. Extracting value today while aligning the future benefits, and putting the utility in the driver's seat.
So we've got a wide topic that we're going to have to find ways to prioritize around. And that's when I'm going to leave it up to our panelists within their introduction. We're going to have 5 minutes each for each panelist to provide that introduction and give their one key point that they need to get on the table for this discussion. So with that said, we decided more or less that we're going to start in this order. I think this kind of works, but we're going to jump and go right to Praveen, and then we'll circle back. Okay? All right, so Dan, will you start us off?
Okay, great. Yeah. I guess my starting out comment is interfaces and integrations are tough and all. When I looked at the topic, that was something that stuck out to me because I'm Dan Smith. I'm the Vice President of Electric Service Delivery at Austin Energy, so I run the wire side of the business, transmission distribution. Have the privilege to lead 550 men and women who I think do just an excellent job in not only delivering reliable, safe power to our customers, but also in delivering technology. And I also need to not pound the table. So, but I think one of the things that sticks out is that it's the platform for really delivering the value to the customers that relates to utility is certainly revolves around the grid. And so there's some foundational technologies that Austin Energy has put a lot of energy into, one of those being an AMI. We've been adopters of ANI, very early adopters of AMI. We actually had an AMR system starting in 2001. We started putting smart meters in the system in 2007, and we're actually at this point where we have full adoption that we're replacing those first generation meters. But the reality is once you establish an AMI, that's really just a starting point. You really need to leverage it, and that's something that I'll talk a little bit more about. A next real foundational technology is an ADMS, an Advanced Distribution Management System, and I come from the transmission substation world, and so as a result of that, we've been putting microprocessor-based equipment, IEDs, in the system for 20, 25 years. There's been a lot of it's been a two-way flow of power and information for years and years. Well, those same principles are now finding themselves into the distribution system, and that's where we're really starting to deliver something different to the customer by doing so. So an ADMS becomes a very foundational platform. What that means is that it's not, you almost have to really kind of define the functionality that you're delivering. And for us, an outage management system was the first part of that we really needed to get right, but then that's moving into what we're doing from an automation perspective. So we're providing things like conservation voltage reduction, FLISR, fault location, isolation system restoration, and then it's really rolling into other applications that enable us to dispatch our resources in a more productive way. And that system is based on an accurate electric model that's a GIS system, and so I can't underestimate what the value is of having a really accurate GIS in an electric model. And that leads to another point that I'd lead into is that this same system that we're operating the system by is the same system that we're planning and modeling the system. So when it comes to determining things related to where we need to install capacitor bank controllers, or ultimately where we have the ability to add DERs in the system, like hosting capacity, all that stuff is based ultimately out of the same model that we're operating the system. And then I believe another integral part of this is then integrating this into a work and asset management system, and those become just key foundational technologies that you just have to deliver in this day and age. And probably a couple of quick lead-ins of some examples of things that we've done, so I'll try to give you some practical aspects. I mentioned the outage management system. I think you've heard it talked about in this conference that you need to have a system such that customers aren't calling you to let you know their power is out, and that's the way we used to operate up until recently. And until we really got that integration, which by the way was not an easy integration between AMI and ADMS, that's how we operated. But once we really got that integration working right, then we now have proactive information knowing the customer's out, and that leads to then how we can communicate directly with them. And so we then attach that to a system that interfaces with the customer, can get a text message if you sign up and say, I want to know, I'd like to get outage information, what my estimated time of restoration looks like. And those are the type of things that we're now delivering. In fact, I was looking at the outage map, by the way, being here in Austin, we definitely watch the storms carefully, and I can let you know that we never drop below 99.8% of our customers without power, so it is not too significant of an event that occurred, but what's really powerful with that is just obviously placing information at the hands of not only the customer, but even the operation folks. And during the Harvey event, I was able to just continue to track real time on my cell phone where we were with outages and all. Another example of things that we're doing is in fact, I was probably the highest paid and the poorest, weakest operator during Harvey. And so at one point around midnight during Harvey, I was in the control center and working with my staff and asked them what they were doing and where they needed help. And it's like, we're out there trying to validate a few customers being restored, more than just a few. And so I was pinging meters, and that's the capability you could do. Sitting there at your ADMS terminal, the operator can go out there and interface, ping a meter and determine, well, is that power restored or not? That's obviously powerful. We're not dispatching another truck into a location that's got a customer restored. At the same time, you're giving the same functionality to your CSRs. And so your CSRs might get a call from a customer and says, hey, I've got a power problem. They have that ability to ping that meter, determine whether or not the problem looks to be possibly in your premise and not at the utility supply, because I can see we've got voltage there. So
Okay.
yeah. I've talked enough? Okay.
No, that was perfect. Yeah. No, you're just getting warmed up.
Oh, yeah.
Yeah,
I didn't get into the shines of DERMS yet. I was ready to.
There you go. That's round two. We got to start off with AMI, and then we'll get to DERMS, and we might get some other crazy acronyms. So Sandee, would you please go next?
Sure. Sandee Simon, I'm the Vice President for Transmission and Distribution at Bridge Energy Group. We are system integrators, real-time systems. We do strategy, consulting, all the way through planning and implementation, integration, and then operational optimization for utilities. We are 100% focused on the utility and the energy industry. So excited to be here, excited about this topic. When we talk to our utility clients about this connected utility concept, talk to them about it being a journey, right? You have to start kind of with the big picture in mind, right, of how do you want to play in this space? What do we envision the world to be? How do we want to influence it? How do we want to be part of that, right? Do we want to be part of smart cities, and what's our role in that, and our connected homes, and kind of all the really, really cool stuff we've been talking about here the last couple of days, right? And then we back up and say, okay, we believe that the utility infrastructure is really the foundation for all of those things. And there are, Dan talked about it, there's a lot of things the utility has going on, right? You're putting automation on the grid and you're putting systems in place, but all of that enables the stuff that's going on at the edge, right? The connected homes and the smart city aspects and the electrification of transportation. We have to make sure that the utility foundation is established so that we can manage and can enable all those cool tools and the services and things like that we've been talking about. And whoever thought, 10 years ago that we'd attend a conference like this talking about augmented reality and virtual reality and how you integrate that information into the utility environment. And we're working with clients to do that, to use things like smart glass to enable, outage restoration and to walk a line and feed that information back into work order management systems and automate that whole process. That's really amazing, innovative, cool stuff for any industry. But I love it that it's part of the utility industry. And I know some of that may feel like it's far away, but my key takeaway that you asked us to do is, yes, you have to begin with the end in mind, and I think that's really important. But we are starting to enable the integration of customers into our processes. We can use things like crowdsourcing to do some of the stuff that traditionally maybe we never could do before because of social media and some of the things we're talking about. And that stuff exists today. So while you have to have a strategy and a roadmap and kind of a plan for how you want to play with that, there are things that you can take. Let's pick one use case. We don't have to boil the ocean and do the 15-year project and the $10 million, $10 billion, whatever effort. You can start making those incremental changes and put together, what's the one use case that would add the most value right this minute. Let's go and let's implement that and get that done and start seeing the value from that. And all of a sudden that start informing the other processes that we're doing. It starts engaging the customer quicker. And I think that's the world that we're evolving into, and that we are starting to walk down that path and that journey with our clients and talking about kind of how do you take these no regret steps. We talked about failing fast, or maybe quick wins is maybe a better way to talk about that this morning. But how do you do that, and how do we, so we're working with our utility clients to do that every day. So.
All right, thank you, Sandee. So speaking of new solutions, let's go over to Praveen, first with an introduction and talk about how what you're doing, and especially the battery storage in general, plays a critical role in this whole conversation.
Thanks. My name is Praveen Kapoor. I'm a Vice President of Market Applications with Fluence, which is a newly formed joint venture between Siemens and AES. So prior to us launching at the beginning of this year, I spent 10 years at AES working on energy storage. So our whole team from AES came into the joint venture, and about 40 of our colleagues from Siemens as well. So Fluence is an energy storage solution provider of battery-based energy storage solutions to utilities, developers, and industrial customers. The other hat I wear is I'm the chair of the board of the Energy Storage Association, which is a trade group that includes a broad set of energy storage technologies and players from all across that value chain. The perspective I want to represent here today is that the adoption of energy storage, especially of batteries in the power sector, represents a fundamental shift in grid planning and operations. And to delve just a layer beneath that on the planning side, we heard this morning from AEP that 40-year, multi-year lead time, billion-dollar capital projects are risky. They are, no doubt. That's inherent to their nature. And storage is enabling a shift in generation, transmission, and distribution planning in a manner that allows you to shrink the minimum scale of a planning increment, and also shrink the timeline. So on the scale, one of the projects that my company has done in partnership with APS is a 2 megawatt, 4-hour duration battery. Doesn't sound like much, but it's at the end of a long line where load is growing, where otherwise there would have needed to been a fairly expensive transmission or distribution upgrade. And by using a battery at the end of the line, the utility was able to achieve the same service to the customers at half of the cost. So you can easily imagine that scaling up as we look at tens of billions of dollars of transmission projects around the country. This is certainly a solution that can be examined to do those in a less risky manner, because especially when they're 5 years out, it's uncertain exactly what the load growth is going to be at that point in time. So you can do things that are smaller, shorter timescales. On the shorter timescales, about a year ago, we provided 2 battery systems to San Diego Gas and Electric that represent the largest build of storage ever, of battery-based storage ever, within 6 months from when it was contracted to when it was built. And so when you think about not just shrinking the size, but shrinking the timescale, it again removes another element of risk from capital planning that completely changes how you look at generation planning for building new peaking plants, as well as transmission and distribution planning for some of the more significant wires upgrades that are out there. Within operations, storage, because batteries can operate very quickly, they can ramp very quickly, unlike a power plant, they can be synchronized to the grid with 0 minimum load, and they can ramp essentially instantly to their full power or any point on their dispatch range from charging to discharging. And so it represents it's a digital power resource in that sense, where real power to manage frequency, reactive power, managing voltage, and synthetic inertia, as we have a changing portfolio of supply and demand, especially as there's customer-led adoption of technologies. As per our session abstract, this does allow the utility to get back in the driver's seat, where some of those forces are happening within the mix. This represents a utility-controlled, in many cases utility-owned resource that can provide the real and the reactive power and the synthetic inertia that is needed for the system to run reliably.
Thank you, Praveen. So Patrick, when you hear the things you've heard so far, how do you pull this all together, and how does it relate to your key priorities?
Yeah. So if I hear, our panelists sharing different perspective, I'm going to try to help you to put together a big picture first, and then I'll tie it in with what we're trying to do to solve those problems, right?
And please give an introduction so people have a sense of your point of reference for this.
All right. So Patrick Lee, work for Sempra Energy today. I'm a vice president of infrastructure and technology for Sempra Infrastructures, and I also is the president of Pice Energy Solution, a new startup company within Sempra, focusing on how to solve our grid's problem. Really starting from the ground up. And so, if I put together sort of an environment perspective to say, hey, today, because of government supporting renewable energy, whether it be, for the green initiative or whatever it is, right? What the market saw is now the cost of solar and wind in large scale, unsubsidized, is lower cost than natural gas and coal generation. That's just a fact, right? When you see wind energy are sold at about 2 cents a kilowatt hours in the Midwest because there's a lot of wind. When you see solar being sold at 4 to 5 cents a kilowatt hours, that's a very low cost energy. And then that created some challenges in terms of integration of the grid that Dan talks about to say, hey, now you have a lot of distributed resources besides large scale. You also have a lot of solar rooftop and so on, and other mini combined heat power fuel cell type technology that utility has to deal with, right? At the same time, these intermittent problems are causing grid management problems that Sandee talked about. We better have some good grid management tools to do it. Then comes after that now we have storage solution that can help shape some of these renewable energy to have maybe a combined lower cost, for the customers. At the end of the day, if you think about this, is say, hey, what problem are we trying to solve? I think customer wants to go green and go higher percentage renewable. Regulators are pushing in that direction. Around the world, people are pushing for that direction, right? And so how do we get there? Well, if you see in the Pacific, the Hawaiis and other that are leading the industry, well, they get to a certain percent of renewable integration. They couldn't get much higher without curtailing these facilities and also putting moratorium on solar rooftop and so on. So we start looking at it from a Sempra perspective to say, well, not only we need to participate and learn about technology, we want to find a solution that can actually address one, how can we operate a power grid with much higher percentage renewable? And two, I think that's the more important part is how do you help integrate more renewable at a lower cost than people think they can achieve today? Because if we just focus on the incremental add of solar and wind and energy storage to the grid, and not think about what we already have implemented in the grid, which is a lot more dollars involved, trillions of dollars of assets already been built, the thermal power plant that we have. You really need a solution that actually can look at more from a system perspective to say, how can I improve the entire system as a whole in terms of efficiency? So the analogy I give you for example that you can relate to would be like a Toyota Prius as a hybrid car. You have an existing thermal power plant, the engine of the car. You add a small battery to it, right? And so when you do that, well, what's really creating the fuel efficiency out of the car? It's the smart engine control system that determines when the battery should kick in, when the engine should work. Together, under any operating condition, together, it created the overall system improvement. Not just the batteries working better, right? But the entire system. So you really have to have a system thinking, a comprehensive solution to think about how do we get more efficiency out of the entire grid, not just the new asset that you're actually working on. So to get there, how do we get there? Well, there are technologies that will already exist in our power grid that we're not adopting. The foundational technology that I think Sandee is very familiar with, that our military pioneer GPS-based technology took us from Morse code communication to now using GPS-based technology to deploy our asset, land, air, and sea, anywhere in the world with maximum effectiveness. It's about utilization of our assets that we have to get maximum impact, right? So if you think about this similar idea, transition to a transportation sector, many of us ride Ubers and Lyft, right? They took GPS-based technology that the military invented, adopted with other enabling technology to solve a system of rider and a system of car problem to provide the services to you to improve the entire system of transportation, right? We have the GPS-based technology in the power grid already since 1982, invented in Virginia Tech. That's called phaser, single phaser. But most people think of that as, oh, what is that? All it is a magnitude measurement timestamp with a GPS time to now converting a magnitude measurement into a vector, a directional vector that you may be more familiar with as, once you have a 100-mile distance, but now I'm telling you 100-mile north, giving you a direction, right? So that's the technology we have now implemented that enable us to get more value out of the grid. And I think there's a lot of opportunity to do that.
Great. Well, thank you for setting the stage a little bit here. But before we get further on round two from panelists, let's get into the audience a little. What are we missing in this discussion that you feel is important to get on the table, that we should be talking about right now or asking ourselves about? What's coming to mind? Yep, back in the back, yeah. Just say your name and company.
Bill Hawk with TRC Engineers. We're hearing a lot about the operations side. Dan briefly mentioned, and I'm just curious about how the customer experience, what are the multiple, if there are areas of your customer exposure that are being brought into the operations and integrated with the operations with these systems that are being put in place? How is this benefiting not just your ability to support your customers, but your customers' ability to interface with the utility and to make intelligent decisions about their energy usage?
And Dan, when you go to answer this question, I just ask
Sure.
that you try to have it come through in 2 minutes.
Okay.
So we can get more of these ideas and
All right,
questions.
I'll talk real fast. So I think part of it, one is really our grid modernization goal has two major KPIs we're looking at. It's not just reliability indices, but we're also looking at really moving the needle on customer indices. So things like JD Power. What that, for example, I appreciated Sandee's comment because it gave us some level of focus to realize we drilled into JD Power, customers saw us as a reliable utility. They did not like it in regard to how well we communicated. We did not communicate well to our customers when we did have a power problem. So that's why there was a lot of focus on bringing two-way outage communication to our customers. So that would be part of an example of delivering something different. It's operationally based. I mean, that information, ETRs, if they got an outage, all that stuff comes from there. But we really had to connect to how we were going to provide that to our customers. No doubt, interval data for customers is a value, and it's really how you get some levels of presentment of that data. So once again, why I believe AMI is a foundational technology is it really does give our customers the ability to have much greater insight into their energy usage. You know, attaching it to other things, customers still want reliability, and so you know, we really do need to connect where they are with SAIDI and safety. And what we're realizing is that the intermittent, the shorter, the things that fall not even a part of SAIDI or safety are actually mattering as well. So back to drilling down to our customers, really understanding them, they do care about the short intermittent type problems as well. And once again, your technology now has the ability to give you that level of insight, and you can get down to the customer basis and determine how many times did they see these, you know, very short type operations where a recloser would have operated. That we think that's great, but we realize no, that's not delivering a customer value to them as well. So maybe some quick examples. I don't know if that's 2 minutes or.
No, you're right in the zone. Let me come to you, Sandee. But before we started, you had this question. Are we getting to what your question was?
Yeah, and I'm just curious. You know, outages are definitely key. I'm from Orlando. We just went through Matthew, and I found it tricky to get information like, hey, if you guys are working on this circuit, then I know these neighborhoods are restored next. And connecting that interface and connecting that information between operations and customer service. But we did a lot of the pinging, like you were saying, and we just did two-way alerts. And I'm just looking for even more ways that collaboration can become more transparent. Did I get across what you wanted me to get across?
Yeah, I actually think it's a great point. I would only state that providing the customer, the CSR, the customer service, customer call center, that greater degree of transparency into it's key. We've been thinking, but we're not there, is figuring out how can they get some level of view with our ADMS that might give some of that level of insight. We are able to make some connection of dots, meaning recognizing that customer is tied to that feeder, and then from there, you know, there's an ability to potentially connect. This is the prioritization that's being worked. As you know, with the type of thing you faced, you know, Hurricane Matthew, Hurricane Harvey, all those have been, you know, massive situations that automation's important and key, because to try to get this thing coming through, I'm going to call the operator, that's not going to happen, right? So it's a great point, and actually I'll take it as a little bit of thought about how we can try to drive a few things more further on our side.
Okay, Sandee, you got a point, and then Patrick will go to you. I think you're about to say something. So
I just wanted, we're early in the stages of this, but some of the things we're talking with our customers about, and our CEO published an article conveniently entitled "The Connected Utility" that went out today. I think our marketing had a little bit to do with the timing on that, and it was talking about how you engage your customers and use these new tools, the social media, the crowdsourcing, and things like that, to help pull, you know, and outages is an easy example, right? How can you use people, you know, walking the streets and sending you information from their cell phone and pictures that help you identify what's going on your grid, you know, and this is not a utility example, but I know some cities, you know, they have pothole applications, and you can send in a picture of a pothole and it opens a work order that pulls into the work order system, and they can go get the potholes fixed. And we're seeing those kinds of technologies and kinds of applications on the utility side as well. And the technology exists to do that. You just have to have the foundational systems in place to be able to handle getting that information and knowing what to do with that data.
Okay, so as we transition to you, Patrick, let's think about this as a component of this discussion. Front lines, reactive, getting better at that point of optimization. But then there's the overall macro optimization of the grid itself to consider, so that those moments happen less upstream. So to you, Patrick.
Yeah, I think that's a great point. I think even in the utility that I worked for many years, we have shifted from informing the customer in terms of letting them know what's happening first before we actually start restoration. Because before, in the old day, we always focus on let's restore the circuit as quick, close the fuse back in, right? So with the advance metering, that we implemented at least 5 years already, now we can actually let customer know and pinpoint a problem quickly where it's at, right? But now when you have multiple problems simultaneously, now you have to look at your resource management to say, can I actually have enough crew to go out there? And then the city required me to have traffic control, and I couldn't get to where I need to do. So that estimation become much more difficult to tell you, is it really 3 hours or 4 hours that's going to restore your power? I think we will improve continuously and get to that point. But I think to HG's point about, well, if you can design a system that's more resilient, maybe you don't have to deal with the outage problem as much, right? So I think with the more distributed asset that we have now, and you have a way to manage these distributed asset with a more local resiliency, then I think some of those problems may be addressed very differently, because now the grid has its own kind of resiliency built in by design, as opposed to, okay, you have a large centralized network. If the source is dead, everyone's out of power. Right?
To achieve that, the relationship between the utility and the consumer has to go through a massive transformation so that investment can go past the meter to the end user, which can create infrastructure optimization that you can't get when limited with the utility trying to do it all themselves. And one thing I've been interested is what causes the driver to have the utility want to take that approach. In most cases, I've seen that's been by a more and more enlightened regulatory group that understands the ability to work for the greater good involves now more opportunities to connect across the meter. And so you'll see things like non-wire solutions, where utilities like Con Edison have to put in, before they do an infrastructure investment, a benefit cost analysis that determines whether or not it is better for them to do the investment themselves, rate base it, or to create a non-wire solution where they can incentivize the end user to make the infrastructure investment and ideally create a more efficient infrastructure, not compromising reliability and potentially actually strengthening it, because you've incentivized a more distributed paradigm by empowering the end user. Curious how we close the loop here. If we really want to make transformational change, it's not just the utility, it's the utility plus the regulator and the end user that are all in this conversation that needs to evolve with an end in mind that we're all excited about. And Praveen, in energy storage, it always comes up as being one of these critical breakthrough components. How do you see that impacting utilities? How do you see it connected to state governments making these very audacious storage goals, and how it relates to cities with their clean carbon futures? So I want you to answer the question. If anyone has a question they'd like to ask, my job is to pass the mic around, so just let me know and I'll get the mic to you. So, Praveen.
Yeah, and I think that's one of the really interesting aspects of energy storage, is that it is a ubiquitous technology. So we're seeing it adopted on the utility side as a capacity solution in the generation realm. We're seeing it adopted as a wire solution in the T&D realm, and we're also seeing it adopted by customers. And as well as in between some of those, there are use cases that span those domains. So including between those last two, like the example that you gave of non-wires alternatives, you could actually have storage that's implemented by a utility at the customer location to solve a grid issue beyond just that customer. So it's a very flexible planning tool in that regard. The topic of non-wires alternatives, this comes up a lot, and I think especially where you end up seeing large, 50 million, 100 million, multi-100 million infrastructure projects that would result in very low utilization when we already have a utilization problem in our grid infrastructure. It's very low relative to other industries. It's a great opportunity. While there is a regulatory and a policy push, as you're describing, for some of these customer implemented solutions, I think storage represents an opportunity for the utility to remain in control, to have a resource that is available around the clock under complete utility dispatch control, that acts as a backstop to anything that would be implemented on the customer side. But it is the type of policy and regulatory regime you're describing that I think is going to drive utilities to actually adopt storage as a wires solution to maintain their competitiveness relative to some of these customer-provided solutions that may show up in a non-wires analysis.
And from your experience with AES, you're one of the leaders in front-of-the-meter distributed storage systems around the globe. So you have that unique perspective on that issue. Any other questions or comments from the audience? Where do we need to take this discussion? What's missing that we need to be talking a little bit more about? Have we solved the problem? Okay, over here.
So Gaurav from Chai One, we're a digital studio. So really interesting conversation around the battery storage and AR, mobility, GIS, the new technologies that are coming into the market. So when you guys think about the interface between operations, customer service, it seems to me like there's two choices. One choice is that you can upgrade your existing systems, and the other is that you can reframe the problem and think about it in a different way and how it could be solved with these new technologies. Can you guys talk a little bit about the pros and cons of upgrading versus reframing the problem and thinking about it in a brand new way?
If anybody can clearly articulate the problem, that would be great.
5 minutes?
He's very generous.
You are punting that one to me. Okay.
We don't have to punt.
So you can do it as a team. You can have.
Go ahead. You have something?
Right. Well, so I think your question is really about, should an end-use customer or should the utility replace an upgrade, or should an end-use customer create utility? Right. So again, right, I have to create a context that we want to talk about this, right? When the market and technology are changing faster than regulation, you created unequal playing fields. It's not fair for the utility and not fair for the entry, the people that want to compete, because the regulation prevent them from competition in or out at the same time. So for example, you have artificial rate structure that are created. All of a sudden, people want to put in solar roof. The one that can afford it will put it in, right? So now you created artificial economic to drive the market for adoption. The same can apply for energy storage because, well, utility has a rate structure for charging demand charge. So people will say, I'm going to put in a battery to cut my demand charge, right? So as a utility or as a customer, you really need to understand when you commit to an asset, whether a utility is going to build a pipes and wire that has a 34-year, 40, 50-year life, to a customer on the end to say, I'm going to adopt a solar roof on my top of the house that has a 20-year life. A lot of the financial variable changes over time. The rate structure changes, right? So it's really hard for any party to make a decision to say, what's the right answer? So for utility, basically say, well, I need to now build more flexible resources. I'm going to put battery in the system that's non-wired that give me some flexibility as the market changes, right? So instead of thinking about, well, should I upgrade? Probably less pipes and wire, right? Just like when we talk about earlier, AEP talked about, well, it's not likely going to have new coal plants. So I think for utilities, we're going to have less likelihood to have transmission and distribution lines. You always will weight the non-wire solution as the alternative also.
Yeah. Oh, go ahead, Sandee.
I was just going to say, I don't think it's an or conversation. I don't think it's one or the other. I think it's an and discussion and a how and a when, right? Because you can't necessarily add all these new things out here without doing something for that foundation to be able, I mean, at the end of the day, it still has to be managed and controlled. And Patrick was talking about that in the beginning, is that's the kinds of technologies, they're doing new technologies and building new things to enable better management of the grid, to enable those edge resources to be able to manage better. So I don't think it's a one or the other, in my opinion.
Okay.
Yeah, I think that I do agree with Sandee, and I think there's several things I'd state that come to mind as this in this discussion. First of all, I don't think it's totally simplistic. One is segmentation of the customer to begin with. So if you think about your customer and their needs, that is not just one linear and single thing. So, and you've got this diversification in your customers, and I think that becomes one of all of our challenges, that we're working through. Meaning, the fact is, it's not one size fits all. I think on the other end of the spectrum, I don't think we want to lose sight, and it was stated, I know it's been on this conference, it's always stated that, I think if Texas were a nation, it's the 5th largest wind producer of the world, right? So that bulk wind, which is largely coming from West Texas, some's coming coastal, but largely West Texas, that's valuable. That is a valuable resource to believe that we should just let it sit out there and not get it to the load zones of Texas, which are pretty much down the I-35 corridor. That's not right, I mean, let's just be honest. So what I'm pointing out here is so to say we're not going to have a wire system anymore because we can pretty much do this by all types of microgrids and things of that nature, I think we're losing sight of overall some of the things we do want to leverage and value. We also have to recognize these things are regionalized, they're localized, there's different things that fit into that as well. So all of that kind of plays into this element, and I think the fact that there is legacy infrastructure faces us with an opportunity to say, okay, I'm not saying all I'm going to do is keep putting poles, wires, and transformers in. However, the poles and wires and transformers I do have in, maybe there's use in that. I need to continue to think about that in the whole equation here as well. And so I don't know how we fully answered your question, but I do think that there's an aspect of working, like Sandee said, it's not an or, it really is an and type scenario.
Okay, we're going to take one more comment versus a question because we're coming to the end of our time. I got just a few set of wrap-up points, but I'm going to let you take it away, Mike. With
Yes, thank you. Again, my name is Mike Myers, and I'm with Allegheny Science and Technology. Just one of the things that I've heard from a lot of residential builders, and maybe this is a little bit more of a Texas deal, but I've had builders who are going out and they're doing 1,000, 1,500 home community. And one of the questions that they're coming to me and saying, well, we really haven't heard that much from the utility in terms of connectability other than here's how we connect. But you have this one-time opportunity to go in there in terms of storage, in terms of wireless and other opportunities there. I think I'm just was real interested in terms of the future, in terms of the utilities working with these large developers going, they can have a real impact on grid and resilience if they're worked for initially.
yes, and so chew on that. Look, we're moving away from a one-way toll booth system to a handshake, where if you think of Shawshank to Redemption, he's running for the train, the dramatic scene where he reaches down, to make the handshake and pull someone along. That's kind of, I see the paradigm here that's going, where it's a handshake model versus a toll booth model. So we need to be able to support both sides. What I'd like to do, just to let you know all of some resources you can tap into. So quarterly I run stakeholder engagement workshops on issues like grid modernization, mobility and transportation, resiliency. And our upcoming Q2 event across Chicago, Boston, New York, and DC is on grid modernization, buildings, and cities. So if you go to a Go Advanced Energy and you go to media, you can see all the 2-minute recap videos from these cities for the past 2 years. And you'll see the utilities, you'll see the regulators, you'll see the large energy users, battery storage providers, and maybe that'll provide some widening perspective on how this dialogue is being hammered out across these different cities. Let's thank our panelists for their time and willing to engage. Thank you.